They demoted it. They erased it from the list of planets. A tiny, frozen world at the edge of the solar system, considered dead and irrelevant. But we went anyway. 3 billion miles, 9 years, one chance to see the truth. And Pluto wasn't dead. It had mountains that erupted ice, blue skies, a heart that beats, and a hidden ocean beneath its frozen surface. We killed Pluto in a conference room in Prague, August 24th, 2006. A group of astronomers took a vote, changed a definition, and just like that, a planet died. Not literally, of course. Pluto didn't explode or vanish. But to us, to the textbooks, to the collective consciousness of humanity, it ceased to exist as a planet. It became a footnote. A cosmic participation trophy. A dwarf planet, which is basically astronomy's way of saying thanks for playing, but you're not quite good enough. The public was furious. Kids who'd memorized, "My very educated mother just served us 9 pizzas," now had to settle for 9 nachos. Teachers scrambled to update posters. T-shirts appeared. Pluto, never forget. But beyond the memes and the nostalgia, most people accepted the verdict. Pluto was small. It was distant. It was irrelevant. Just a frozen pebble at the edge of nowhere, not worth our attention or our spacecraft budget. Here's the problem. While we were busy having our little debate on Earth, arguing over semantics and planetary qualifications, Pluto was keeping secrets, big secrets. And in 2015, when we finally sent a probe to check on this insignificant rock we'd just demoted, what we discovered was so shocking, so completely unexpected, that it made the demotion look less like science and more like cosmic arrogance. Because Pluto wasn't dead. It was furiously, violently, impossibly alive. It had blue skies. It had mountains that erupted ice. It had weather, seasons, and a nitrogen glacier the size of Texas that literally breathes, expanding and contracting with the centuries. And hidden beneath miles of frozen crust, it was hiding an ocean, an actual liquid ocean that might, just might, contain life. We thought we were visiting a corpse. Instead, we found one of the most dynamic, bizarre, and potentially habitable worlds in the entire solar system. So how did we get it so spectacularly wrong? What is actually happening on this strange little world at the edge of darkness? And why are NASA scientists now saying that demoting Pluto might have been the biggest scientific mistake of the 21st century? Buckle up. We're taking a 3 billion mile journey to the planet that refused to die. Let's talk about just how insane it was to even attempt this mission. For 76 years, Pluto was nothing more than a mathematical ghost. When Clyde Tombaugh discovered it in 1930, he found it the old-fashioned way, by comparing thousands of photographic plates, looking for a dot that moved against the background stars. That's it. A moving dot. That's all Pluto was to us for decades. Even when the Hubble Space Telescope, our most powerful eye in the sky, turned its gaze toward Pluto in the 1,990 seconds, it could barely resolve anything. The images looked like someone had smeared Vaseline on a webcam from 2003. Pluto was a pixelated blob of brown and white. We could make out vague patches, maybe poles, maybe equatorial regions, but that was it. Trying to understand Pluto from Hubble images was like trying to read a book by looking at it from across a football field through a fogged-up window. We needed to go there. But going there was borderline impossible. Pluto orbits approximately 3.67 billion miles from the Sun. That's 39 times farther from the Sun than we are. To put that distance in perspective, if the Sun were in New York City and Earth were in Philadelphia, about 95 miles away, Pluto would be in San Francisco. If you got in a commercial jet and flew toward Pluto at cruising speed, it would take you roughly 690 years to arrive. If you drove a car at highway speed, non-stop, no bathroom breaks, you'd get there in about 6,300 years. The ancient Sumerians, who invented writing, could have started driving toward Pluto and they'd just about be arriving now. NASA didn't have 6,300 years, so they built a bullet. New Horizons launched on January 19, 2006 from Cape Canaveral. It was roughly the size of a baby grand piano, weighed about 1,000 pounds, and left Earth moving at 36,373 miles per hour, making it the fastest object humanity had ever launched at that time. It passed the Moon's orbit in just 9 hours. The Apollo astronauts took 3 days to make that same journey. By the time New Horizons crossed Mars's orbit, it was already too far away to be captured by the Sun's gravity and pulled back. It was committed. It was locked on a one-way trajectory to the edge of the solar system, but even at that blistering, record-breaking speed, the universe is just too incomprehensibly large. The journey took 9 years, 5 months, and 25 days. For nearly a decade, New Horizons slept. It coasted through the black void, powered down to conserve energy, its instruments cold and dormant, waiting. The engineers would wake it up once a year for a systems check, make sure nothing had broken, then put it back to sleep. It sailed past Jupiter in 2007, using the giant planet's gravity as a slingshot to gain even more speed, and then nothing. Just silence. Just darkness. Just the slow, patient crawl through space. And while New Horizons slept, Pluto's fate was being decided back home. In August 2006, just 7 months after the probe launched, astronomers gathered in Prague for the International Astronomical Union's 26th General Assembly. They voted. They redefined what a planet was. New rule: a planet must clear its orbital neighborhood of debris. Pluto hadn't done that. Pluto failed the test. Demoted, downgraded, discarded. The public lost interest. Media coverage dried up. People started asking, why are we spending $700 million to visit a dwarf planet? Why send a grand piano to look at a glorified asteroid? Some scientists began calling New Horizons the mission to nowhere. But the spacecraft didn't care about definitions. It just kept flying. On December 6, 2014, after 8 years and 11 months of sleep, New Horizons finally woke up for good. The hibernation was over. It began its approach sequence, and on July 14, 2015, at 7:49 a.m. Eastern Time, traveling at 31,000 miles per hour, New Horizons screamed past Pluto at a distance of just 7,800 miles. It had one shot. There was no slowing down, no orbiting, no second chances. The flyby lasted just a few hours. Every instrument fired simultaneously: cameras, spectrometers, plasma detectors, dust counters. The probe spun and twisted like a dancer, pointing different instruments at Pluto and its moons, capturing as much data as physically possible in that tiny window of time. And then it was gone. Pluto shrank behind it. New Horizons kept flying deeper into the Kuiper Belt, leaving the dwarf planet behind forever. But the data, the data. Because of the vast distance, it took 4.5 hours for each radio signal to travel from New Horizons back to Earth. The spacecraft's antenna could only transmit at about 1 kilobit per second, slower than a 1,990 seconds dial-up modem. It took 15 months to download all the pictures and measurements. And with every new image that trickled in, scientists' jaws dropped a little further. The first high-resolution image arrived on July 15, 2015. When it popped up on screens at Mission Control, the room went silent. Then someone whispered, "Oh my God." It wasn't gray. It wasn't dead. It wasn't a boring ice ball. It was red. It was white. It was tan and gold and rust-colored. It had mountains casting sharp shadows. It had plains smooth as glass. It had ridges, valleys, and dunes. It had textures and colors and complexity. And there, staring back at humanity like a Valentine from the edge of the solar system, was a perfect white heart. That heart wasn't just photogenic. It was a warning. It was Pluto's way of saying, you have no idea what you're looking at. Let's talk about that heart, because it's not just a charming coincidence of geology. It is the single most important feature on the entire planet. It is the engine, the battery, the beating core of everything strange that happens on Pluto. When you look at a global map of Pluto, the heart is impossible to miss. It's a massive, brilliantly white region spanning roughly 1,200 miles across, dominating nearly a quarter of the visible hemisphere. NASA officially named it Tombaugh Regio, after Clyde Tombaugh, the astronomer who discovered Pluto in 1930, but everyone just calls it the heart. The heart has two lobes like a real heart. The left lobe is called Sputnik Planitia, named after Sputnik 1, the first artificial satellite. Sputnik Planitia is approximately 600 miles wide and 2.5 miles deep. It is, without exaggeration, one of the most scientifically perplexing places in the entire solar system. Why? Because it is smooth. Now, I need you to understand something. In the outer solar system, smooth is wrong. Smooth is suspicious. Smooth is impossible. Pluto lives in the Kuiper Belt, a region of space beyond Neptune filled with millions of icy objects, rocks, and debris left over from the formation of the solar system 4.6 billion years ago. It's a cosmic shooting gallery. Everything out there should be absolutely pummeled with impact craters. When you look at our moon, it's covered in craters. When you look at Mercury, same thing. When you look at Callisto, one of Jupiter's moons, it looks like it lost a fight with a shotgun. Billions of years of getting pelted will do that. But Sputnik Planitia? Not a single crater. Not one. It's smoother than a marble countertop. This means the surface is young. Impossibly young. In geological terms, it was born yesterday. Scientists estimate the surface is less than 10 million years old, possibly as young as 500,000 years. That's nothing. That's a blink. Earth is 4.5 billion years old. Pluto is equally ancient. But this surface? Fresh as morning dew. Something is erasing the craters. The surface is being continuously repaved, resurfaced, renewed. But how? Pluto's surface temperature is negative 390 degrees Fahrenheit. At that temperature, water ice is harder than granite. Rock is frozen solid. Nitrogen, oxygen, methane. Everything we think of as gases are frozen into solid form. Nothing should be able to move. But it does. When scientists look closer at Sputnik Planitia, they notice something bizarre. The surface wasn't uniform. It was divided into giant polygons like a massive honeycomb or a cracked eggshell. Each polygon is roughly 10 to 20 miles across. They're separated by shallow troughs, and they fit together like puzzle pieces covering the entire basin. What are these? They're not cracks. They're not impact features. They're convection cells. Here's what's happening. Sputnik Planitia is filled with nitrogen ice. Not water ice, nitrogen ice. On Earth, nitrogen is a gas. It's what you're breathing right now, making up 78% of our atmosphere. But on Pluto, it's so cold that nitrogen freezes solid, it forms glaciers. But here's the twist. Even though nitrogen ice is solid, it's soft. It's malleable. It flows like a very slow, very cold fluid. Think of it like the consistency of toothpaste or cold peanut butter or glacier ice on Earth. Technically solid, but if you give it enough time and pressure, it will flow. Now, deep beneath Sputnik Planitia, there is a heat source. We'll get to what that is in a moment, but trust me, it's wild. That heat warms the nitrogen ice at the bottom of the basin. Warm ice is less dense than cold ice, so it rises. It bubbles up toward the surface, just like a blob in a lava lamp or a bubble in boiling oatmeal. When it reaches the surface, it spreads out, cools down in the freezing vacuum of space, becomes denser, and sinks back down at the edges. This is called convection. It's the same process that drives Earth's weather, ocean currents, and even the motion of tectonic plates. But on Pluto, it's happening with solid ice. Each polygon represents one convection cell. The center of the polygon is where warm ice is rising. The edges are where cold ice is sinking. The troughs between polygons are the downwelling zones, where the cold material plunges back into the depths. This process is slow by human standards. Each convection cycle takes roughly 500,000 years, but in geological terms, it's fast, and it means the surface is constantly turning over. If a meteorite hits Sputnik Planitia and creates a crater, that crater will be erased within a few 100,000 years as fresh ice wells up from below and smooths it over. The heart isn't just sitting there. It's churning. It's bubbling. It's alive. But the nitrogen isn't staying put. Sputnik Planitia is also a weather engine. During Pluto's summer, which lasts about 60 Earth years, the nitrogen ice sublimates. It turns directly from solid to gas. This creates a thin atmosphere. The gas drifts across the planet, carried by weak winds. When it reaches colder regions, it freezes again and snows back down. This means Pluto has weather. It has a nitrogen cycle, similar to Earth's water cycle. Nitrogen evaporates from the heart, travels across the planet, and snows down in other regions. Over millions of years, this creates nitrogen glaciers that flow back towards Sputnik Planitia, like rivers flowing back to the ocean. The heart is literally breathing, expanding in summer, contracting in winter, pumping nitrogen around the planet, driving the climate, shaping the geology. And if you think that's crazy, wait until you see what's happening at the mountains. Volcanoes are terrifying. On Earth, they erupt with molten rock at temperatures exceeding 2,000 degrees Fahrenheit. They spew toxic gases, pyroclastic flows, and ash clouds that can bury entire cities. Pompeii, Krakatoa, Mount St. Helens. Volcanoes are disasters. Pluto has volcanoes too, but they are the opposite of Earth's volcanoes. They are bizarro world volcanoes. Instead of fire, they erupt ice. Instead of lava, they spew slush. They're called cryovolcanoes, and they might be the weirdest geological features in the solar system. On the southwestern edge of Sputnik Planitia, New Horizons spotted two massive mountains. The larger of the two is called Right Mons. It's roughly 90 miles wide at the base and stands about 13,000 feet tall. For comparison, that's about half the height of Mount Everest, but much wider. It's a shield volcano, similar to Mauna Loa in Hawaii. But Right Mons doesn't have a peak. Instead, it has a gaping hole in the center, a caldera roughly 35 miles across, and the sides of the mountain aren't smooth. They're lumpy, hummocky, covered in strange mounds and irregular terrain. For years, scientists argued about this feature. Was it a volcano? Was it just an unusual impact crater? Was it a collapsed region caused by subsurface melting? Then, in 2022, a team of researchers used 3D modeling to analyze the terrain in detail. They looked at the texture, the slopes, the distribution of material. Their conclusion: it's definitely a cryovolcano, and it probably erupted within the last billion years, possibly much more recently. Instead of erupting molten rock, Right Mons erupts a slushy mixture of water, ice, ammonia, methane, and nitrogen. Think of it as a cosmic smoothie. When pressure builds up beneath the surface, this slushy material forces its way up through cracks in the crust. It oozes out onto the surface like toothpaste from a tube, or like the slow crawl of a glacier. But unlike a lava flow, which is liquid and flows quickly, cryovolcanic material is thick and sluggish. It creeps across the landscape at a glacial pace, literally piling up in lumps and mounds. Then, because it's exposed to the vacuum of space at -400 degrees, it freezes rock solid. This is mind-blowing for one simple reason: it shouldn't be possible. Volcanoes require heat. On Earth, we have volcanoes because our planet has a molten iron core. The Earth's interior is still hot from its formation 4.5 billion years ago, plus we have radioactive decay constantly generating heat. That internal heat melts rock, which rises as magma and erupts as lava. But Pluto is tiny. Its diameter is only 1,476 miles, smaller than our Moon. According to every model of planetary science, a rocky body that small should have cooled off billions of years ago. It should be geologically dead, frozen solid all the way through, with no heat left to drive volcanic activity. So where is the heat coming from? The leading theory involves radioactive decay. Deep in Pluto's core, there's a rocky center containing radioactive elements: uranium-238, thorium-232, potassium-40. These isotopes are unstable. They slowly decay over millions of years, releasing heat as they break down. It's a slow, steady nuclear burn that's been going on for 4.6 billion years. This heat isn't enough to melt rock, but it's enough to melt ice. Remember, we're not talking about lava here. We're talking about slushy water ice mixed with ammonia and methane. Ammonia acts as antifreeze, lowering the melting point dramatically. So even at temperatures well below freezing by Earth standards, this mixture can remain partially liquid. That slushy mixture accumulates in chambers beneath the surface. Pressure builds. Eventually, it finds a weak point in the crust, a crack, a fault line, and forces its way up. It erupts, it flows, it builds mountains. But here's the kicker. This process might still be happening. Right Mons might not be extinct. It could be dormant or even active. We don't know, because New Horizons only flew past once. We didn't stick around to watch. If Pluto does have active cryovolcanism, it would make it one of only a handful of worlds in the solar system with ongoing volcanic activity. Earth, obviously. Io, Jupiter's volcanic nightmare moon. Enceladus, Saturn's tiny moon that sprays water into space. Triton, Neptune's captured moon. And possibly Pluto, a tiny, frozen, supposedly dead world at the edge of the solar system erupting ice volcanoes. If that doesn't redefine what we think of as an active planet, I don't know what does. But the weirdness doesn't stop there, because when you look up at the sky on Pluto, you see something that should be impossible: blue. After New Horizons completed its flyby, it did something incredibly clever. It spun around and looked back at Pluto, positioning the dwarf planet between itself and the Sun. This created an artificial eclipse, with Pluto blocking the sunlight. And in that moment, backlit by the Sun, Pluto revealed one of its most beautiful secrets. It has an atmosphere, a thin, hazy atmosphere that glows with a stunning blue light. If you stood on the surface of Pluto and looked up, you would see a sky the color of a pale sapphire. The Sun would appear as nothing more than an extraordinarily bright star, about 1,000 times dimmer than it appears from Earth. But the atmospheric haze would scatter that sunlight, creating a soft, ghostly blue glow across the horizon. On Earth, the sky is blue because of Rayleigh scattering. Nitrogen and oxygen molecules in our atmosphere scatter shorter wavelengths of light, blue and violet, more than longer wavelengths, red and orange. That's why the sky is blue during the day and red at sunset. Pluto's blue sky works differently. It's not caused by gas molecules. It's caused by tiny solid particles called tholins. Tholin is a term coined by astronomer Carl Sagan. It comes from the Greek word for muddy or murky, and it refers to complex organic molecules that form when simple chemicals are exposed to ultraviolet light or radiation. Tholins are basically cosmic gunk, the building blocks of life, but not life itself. Here's how they form on Pluto. Pluto's atmosphere is thin, but it exists. It's mostly nitrogen gas, about 90%, with small amounts of methane, a few percent, and carbon monoxide. High in the atmosphere, about 200 miles above the surface, ultraviolet light from the sun hits methane molecules. That UV light is energetic enough to break the chemical bonds holding the methane together. The molecule shatters into fragments, hydrogen, carbon, and other radicals. These fragments are highly reactive. They immediately start bonding with other fragments, forming chains and rings. Methane, CH4, breaks apart and recombines into ethane C2H6, acetylene C, 2H2, ethylene C, 2H4, and more complex hydrocarbons. These molecules collide and stick together, forming longer and longer chains, eventually creating massive, complex organic molecules. Tholins. Tholins are heavy. They don't stay suspended in the atmosphere like gas molecules. They slowly drift downward like smog particles or toxic snow. As they fall through the atmosphere, they scatter sunlight. Blue light scatters more efficiently than red, just like on Earth. That's what creates the blue haze. But when tholins finally reach the surface and land on the ice, they don't stay blue. Exposed to cosmic radiation and solar UV, they undergo further chemical reactions. They polymerize, they oxidize, they turn dark red, then brown, then almost black. This is what explains one of Pluto's most striking features, the blood red stain next to the heart. Remember that massive dark region adjacent to Sputnik Planitia? It's called Cthulhu Macula, yes, named after H.P. Lovecraft's cosmic horror monster. It spans over 1,800 miles and is one of the darkest, reddest regions on Pluto. Cthulhu isn't made of rock. It's not a lava field. It's made of tholins, billions of years' worth of organic snow falling from the sky, accumulating in thick layers, baking in radiation, turning into a reddish-brown tar-like substance. Think of it like this. Imagine a white car parked outside for 100 years. Over time, dust settles on it. Pollen, soot, grime. Eventually, the car is no longer white. It's coated in a layer of dark, sticky buildup. That's what's happening on Pluto. Except the dust is organic molecules raining from the sky, and it's been accumulating for 4 billion years. The really wild part? These tholins are organic molecules. They contain carbon, hydrogen, nitrogen, the basic ingredients for life. They're not alive, but they're the chemical precursors to life, and they're falling like snow across Pluto's entire surface. Which raises a fascinating question. If these organic molecules are accumulating on the surface, and if there's liquid water beneath the ice, could they ever come into contact? Could there be a chemical pathway from surface organics to subsurface ocean? Because that's where things get really interesting. The idea that Pluto might have an ocean sounds absurd. It's 3.67 billion miles from the Sun. It's negative 400 degrees Fahrenheit on the surface. Water should be frozen solid, end of story. But the universe doesn't care about our assumptions. The first hint came from the cracks. New Horizons photographed massive fractures running across Pluto's surface, canyons, chasms, and fault lines stretching for hundreds of miles. Some of these cracks are several miles deep. This kind of terrain is called extensional tectonics. It happens when a planetary crust is being stretched, pulled apart from the inside. Think of a water balloon being inflated as it expands. The surface stretches and eventually splits. On Earth, extensional tectonics happen at mid-ocean ridges where tectonic plates pull apart. On Pluto, there are no tectonic plates. So what's causing the stretching? The answer? Freezing water. Water is weird. Unlike almost every other substance in the universe, water expands when it freezes. This is why ice floats and why frozen pipes burst in winter. If Pluto has a subsurface ocean, and if that ocean is slowly freezing over geological time, the ice would expand, pushing outward. cracking the crust. NASA scientists think that's exactly what's happening. Pluto is slowly freezing from the inside out, and as it freezes, it's expanding, creating those massive fractures we see on the surface. But the smoking gun isn't the cracks. It's the heart itself. Remember Sputnik Planitia, that enormous nitrogen-filled basin? It's not just a pretty feature. It's a clue, a very heavy clue. Sputnik Planitia is a depression, a massive hole in the surface filled with dense nitrogen ice. Pluto's heart-shaped region, Sputnik Planitia, is so heavy it should have tipped the dwarf planet over. Orbital physics says it should have drifted away from Charon, but it didn't. The only explanation that works is a hidden subsurface ocean. Beneath the ice, a dense, salty, ammonia-rich liquid layer acts as a counterweight, locking the heart in place. Models confirm it: no ocean, no stability. That ocean is buried under 180 miles of ice, likely briny and ammonia-rich cold, but still liquid. It touches Pluto's rocky core, creating chemical energy zones. On Earth, wherever water meets rock, life exists. Pluto has water, organics, energy, and time. No proof of life, but enough ingredients to make it one of the most intriguing ocean worlds. Pluto and Charon are also a true binary system, locked face-to-face forever, orbiting a shared point in space. And Pluto is literally painting Charon. Escaping methane from Pluto freezes on Charon's dark pole. Then UV light turns it into red organic material. The result is Charon's eerie red Mordor cap. Pluto isn't small or insignificant. It's active, complex, and possibly alive beneath the ice. If mysteries like this fascinate you, and you enjoyed this journey to the edge of our solar system, don't forget to like the video and subscribe for more cosmic discoveries.